can find any probabilities. So, what is going to go in this box? 18. Because it said 18 men said college. So 18 is for our men in college. What's going to go here?
13. What? I was looking at the wrong one.
12. Because 12 men said high school. And so what's going to go over here? 30. It's the total of the men they talked to. They're right there on my little... Right. Questions on where any of those came from? All right, then what about this box? 13. Because 13 women said college. What's going to go here? 7. How'd you get 7? 20 minus 13. Because they said 13 out of 20 women, so it's not that we were told how many women said high school. We were told the total. So then how many people went to college? What goes here? 31. How many people only went to high school? 19. I don't say only in a bad way, just saying like absolutely fair. All right, what's our total? 50. So step 1 was to fill in this table. We have to have this information in order to do the probabilities. Doing it from the text is a whole lot harder. So that's the work we have to do before we even get to the questions. So what is the probability that someone went to college? 31 out of 50. Good. How about number 2? 7 out of 50. That's straight up where they cross. That's our intersection. It's the and. So then how about number 3? How'd you get that? That's exactly what we're going to do. So when we're looking at the or, that means we're joining these two things together. So I need my men, and I need my people who attended college, and we're going to add those together. So we're going to take our 30 out of 50 and our 31 out of 50, and we're just taking the two groups to put together into one standing up group, and so we're just adding those together. And then we need to watch out because we did have one group we counted twice. That was our 18 college men. So that's when we subtract. And we're gonna get, what's it gonna be? $43? I think I tried to turn my fans up today also. It's a whole lot. Yeah, 43. Yeah, it should be 43. All right, our last one up here. What's number 4 going to be? Out of?
College, if we know they're winning 13 over is 31.
Which is the thing we know?
That they're women.
That they're women. I know they're a woman. Locked in, they're a woman.
13
Out of 20. Out of 20 is how we do that. I know, locked in, they said woman on the survey. Okay? So these kinds of problems are going to show up a lot, especially as review questions, because honestly, right now it's the only thing we've already done is our probability statistics. So we'll see these come up a lot because the final for the semester is over the whole year. So these will pop up as review questions fairly frequently, especially for a while. Okay, so any questions on these as of right now? Okie dokie. So before we do anything else, you guys actually do get a textbook. What? Shock. It just didn't have what we needed for the last chapter in it. So what you're going to do, and I'm done talking, is you're going to come up here and you're going to grab one of these lovely workbooks. You are then going to select a Sharpie. I have a variety of colors. I don't want that one, it's too little. And you're going to write your name somewhere on the front cover or on the edge. I don't care. I do recommend writing my name inside just so in case it gets lost, they'll give it to me and I can get it to you. It's a lot easier. So yeah, do that. That box has a kind of gentle. The chair is slightly wobbly. So grab a book, grab a Sharpie, write your name on it. This is your book. I'm taking the ultimate Sharpie. And you can share Sharpies, like you don't all go. But I have a variety of colors. Probably have to share chocolate orange. Because I only got one black marker and they were the only black one. Go get your own book.
Hey, I lost the folder for this class. I'm sorry.
What's that?
I don't know where the folder for this class is.
It's okay, we start a new chapter, you don't need a folder.
But where's my forgetting?
And then get out a notebook or something you can plan to take notes in. I know we've been going to your packet, but we need a notebook for this class. If you do not have a notebook, I have a few. So no.
Try to get a notebook. I got this thing, and I got that jacket. Them shirts is $70. That jacket was $110. They be taxing this keychain was $20. Huh? I did like it. They got some good stuff in there. I was giggled down. I got my pops a whole set too. For his birthday. His birthday was yesterday. Huh?
When did you get paid?
Oh, I just be having money. You know, I'm like that. Out in the streets.
Huh? Yeah. That works. All right, you guys do not need to bring these with you to class. I will give you guys graphs if we ever need to look at something in there. So this is mostly for you guys to have. It works super duper great in a lot of the other classes. Unfortunately, the way they printed this one, they didn't leave like hardly any blank graphs. They always like, we're gonna figure out how to graph this, and then it's all already graphed. So we're not going to use this to take notes kind of like they did in geometry last year. I know it had a lot more things that fit and a lot more open space. If you look through ours, there's very little actual open space in here. So it's more like a textbook than it is like a workbook for us, just the way it got designed. And so we're not going to use it quite as an interactive workbook. This is just more like a book. It does have in here the like homework questions. like this. If you prefer the pages like this, that's fine. You can do that. I'll give you guys the questions. I also am still going to print them out on worksheets. So they're literally the exact same questions. Just only the ones I picked. Like this one right here is this one right here. They're the exact same pictures. So you don't have to do both. Oh, I printed one that was single-sided. But it'll be there as an option, so that's really great if you have, you know, days that we're out, that kind of thing. But so you guys can take this home, put it in your room, desk, locker, whatever you need. Mostly we're going to be in your notes. And we're doing notes on paper. So get out your notebooks. We're going to use these 4 vocab words today. These are the things we're going to go through. And we should hopefully know at least 2, hopefully 3 of these. We have probably heard domain and range before. What's up? Yeah. Spiral composition. Blue board these. Alright. So we're going to divide these. What's up? This is chapter 1. So if you're looking through that workbook, it's the very first. Like we're going to be using pages 3 through 8 today. Like I said, we're not using the pages, but it's the stuff that's on pages 3 to 8. All right. So you've heard these words before, but maybe not in a while. Does anyone remember what domain is? Say it louder. I heard something, and I think it was right. Say it again. Our domain is our x values. It's the x values, also known as the input of an equation or graph or any other sort of relationship. That says relationship. So if the domain is the x values, what's the range? The y values. Which we will also sometimes call the output. Of an equation, graph, or relationship. And then one you probably heard back in Algebra 1, I think it was kind of near the end of the year, that was function. Do you remember what a function is? We work with them a lot. And in fact, we work with them almost exclusively after today. We're going to have very rarely when we're dealing with things that are not functions. And because a function is a graph or relationship or equation. So it's about these domain and range things. So the way I'm putting this is a graph, equation, or relationship. I don't know why I switched the order from above, but I did. Graph, equation, relationship. where each input has only one output. Which we will also sometimes word it as each x has only one y. Only one output. I will make it be 1. There we go. Which sounds super weird and super complicated and randomly mathy. A function and kind of the best real world way to think about this is a vending machine. If I push the Sprite button, I expect a Sprite to come out. The input, what button I push, gives me one output of getting a Sprite. If I hit the Coke button, I expect a Coke. If I hit the Coke button and I get a Mountain Dew, machine's broken. It's not functioning properly. Oh snap, look at that tie-in.
Or they put it in the wrong spot.
Or they put it in the wrong spot, but it's still not functioning properly. So each x has only one y. If it had like a random button, that would make it not a function because it would give me Coke and then Mountain Dew and then Diet Pepsi and chaos would happen. Because it would be random, that one input was giving me more than one output, different flavors. So it's our vending machine. We're going to do this mostly testing on graphs, and we're going to use something called our vertical line test, and I will show that to you in just a little bit, but I want us to write it down here too. This is our vertical line test. All right, what one we probably have not seen is the one-to-one function. I don't believe we touched that in Algebra 1. At least we didn't used to, so if you've seen it, great, but if not, I understand. So a one-to-one function, first things first, it is a function. So it meets all the rules of a function first. So each x has to go to only one y. It's a function. Where each y, or each output, comes from only one input. Meaning there's not 3 different buttons that'll give me a Coke. There's only one button for Coke. There's only one option to get that Coke. There's only one button for Diet Pepsi. I'm getting a Diet Pepsi there. There's no other options. If there's more than one button to get me to that same answer, more than one x to get me to that same y, it's not a one-to-one function. And when we're looking at pictures, the way we're going to test this is something called the horizontal line test. And again, I will show you what those are here in just a minute. And I'm going to give you guys a second to finish writing that down. And then we have one more thing we need to remember before we get into what we're doing with our domain and range and function tests. We're going to do all of those today. All right. So we're going to look at these 2 number lines. And I want us to try and write inequalities for each of them. I made them very simple so you guys could just like quick sketch these in your notes. If you want them, I do recommend having them. I'm going to show you something weird. So how could we write an inequality for this? Let's say we've got something like an x. Let's use our variable x. If x is in the blue section, what's its relationship to 2? Is x going to be bigger than or smaller than or less than? X is less than 2. Will it be equal to 2?
No.
Why not?
The circle is
Because the circle's open. So it's not equals to. How about the bottom one? Greater than or equal to 2. Awesome. Excellent. That is exactly what I wanted us to see here. We are going to use a new notation as well to write things like domain and ranges. These are absolutely going to work as well. But we're going to have something new. It's called interval notation. And what we're doing is we're really writing it, it looks like an ordered pair. And it's the smallest possible value and the biggest possible value. So on the blue one, my biggest possible value is 2. That's the biggest it can be. But I can go as small as I can imagine. Forever and ever 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 and ever. So it can go to negative numbers, left of 2, all the way down to infinity. So we're going to be using infinity a lot this year. So this is going to go from negative infinity to 2. The smallest possible thing. And we're going to use parentheses on this. So smallest possible value to our biggest possible value. All right, on the pink one down here, what is the smallest we can have our pink line be? 2. What is the biggest the pink line's going to be? Infinity. It keeps going forever and ever and ever and ever and ever. I'm going to put a parenthesis on the right-hand side. But I want us to notice one thing. What is different about the 2 number lines? One's filled and one's not. Because one's equal to and one's not. The ones that have an equals to, we're going to take that parenthesis and make it really square. We put what's called a square bracket on it. That indicates that we can have it equal to. The parentheses mean they can't be equal to, not equal to. The reason we use parentheses on the infinity parts is because you cannot actually equal infinity. Infinity is an idea. It's not a number. And we are going to use this notation all year long. This is going to be how we write domain and range. We will often write it in both, especially in this first chapter. I'm going to write things in both all the time. But more often than not, we are going to start leaning towards that interval notation. And if you know you're going to be taking pre-cal, that is how we write domain and range pre-cal. Consistently and reliably. We almost never use algebraic notation. Okay, and so we're going to practice identifying domain and range on some bigger graphs. And we're going to do some tests to see if things are functions. So when I give you guys a graph like this, I print them. You do not have to sketch them. In the little boxes that are on the table, there are scissors and glue sticks. I usually have these set up so you don't necessarily need to cut them, but you can. If you glue them into your notebook, like up and down like this, we're doing this one first, this one second, and that one third. So I set them up and they're right side up like that. And so whenever we're working with graphs, I will hand these out. If you do decide you need to cut it apart, please pick up your own graph. Melting already. Oh my gosh.
don't know. They said BD was his.
No, BD. And I
They said it was trash.
But there should be at least one pair of scissors, usually 2 pair of scissors, and at least 1 glue stick in the box on your table. Yeah, you're gonna put this in your notes. I was like, I have mine glued in right here. Like, but you can also cut it apart into the separate graphs if you want to. We're just looking at them one at a time. You can cut in between the graphs if you want to. You don't have to. And we might not get to all 3 today. I want to make sure we understand where we're going, and we're going to use this stuff tomorrow as well. So if we need to, we can catch up on the last one, the last day, or tomorrow. All right. This graph is also supposed to have arrows on the end of the lines. So draw your own arrows in on the lines. It does have arrows. It just, the software we use to make the graphs that have readable numbers don't put arrows on it because it's a digital graph calculator. What's up? Yeah. Yeah, absolutely fine. I just try, I was like, I know some people like to work vertically, some people like to work sideways. I don't care what you guys do with them, it's your notes. I will cut them out into these little bookmark things, but if you want more cutting than that, it's on you. All right. So what we're going to do first is we're going to try and figure out our domain and range. Our domain, we just talked about those are the x values we can use. And sometimes it helps to think about it as a number line. Domain means I'm taking my whole thing, I don't care what my y values are, and smashing it flat. So if I smash this whole graph flat, it would look like this if I just made it a number line, right? If I just take a big anvil, a giant cartoon character step on it, smash flat, it would make the whole thing go meh. What would the smallest possible x value I could use be? I can't hear y'all over that thing. It's too loud. So I know it looks like we've got -3 here. It's crossing right there. I love that we saw that -3, finding it up here. And then it's going to go up to -4. And then it's continuing up and up and up and up and left and left and left and left and left and up and up and up and up and left and left and left and left. It's going up really fast, but it is still going left. So what's the very, 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 very smallest it can be? When is that arrow going to stop me? Yeah, it's never going to stop me. So it's going all the way left to negative, that's not a pen, to negative infinity. Goes all the way from negative infinity. What's the biggest it's going to be when I go the other direction? But yeah, if I follow this line up, it goes up, and I'm going up and over and up and over and up and over this way. It's never going to stop me until I run out of leg and or ceiling and or wall. So the biggest it can possibly be a positive infinity. All the way over to infinity. I can go from as small as I can possibly imagine to as big as I can possibly imagine, with nothing in between to stop me. So putting this in interval notation is just like that. We take where those arrows would be. My negative infinity to positive infinity. That's our interval notation here. Oops, I am in the wrong spot right there. I'm sorry. That is our domain. All right, I'm just going to have to erase it. Boop. I was too far to the side and didn't notice I was in the wrong section. It's from negative infinity to positive infinity. If we wanted to write this as an inequality, it's not super intuitive because I don't see what kind of rule it could be. Sorry. Okay, so there's not really an inequality that I see here. I can't do like x is. That's what we're talking right now. So I can't see like x has to be bigger than something or x has to be smaller than something. X can be anything. Anything in the entire universe I can possibly imagine. So the way we're going to say that is we're going to say it can be all numbers, or in fact all real numbers. So you can either write that out where it says all real numbers. It can be anything. If you want a lazy shortcut way to do that where we don't have to write out 3 whole words, you do a capital R and you do an extra line. That means all real numbers. And all that means is I can pick any number that we have ever interacted with in our entire life so far. Because we've not dealt with anything other than real numbers. Eventually we will get to the point where we actually do with stuff outside the real numbers. Fancy schmancy, but I think it's not till next semester. So that's how we're doing our domain. For our range, we're going to do the same thing, but for our y's. So again, if it helps with domain, it's smashing it flat like this. Range, we can think about it smashing flat this way. I just care about the y's. I don't care about what the x's are doing. So for my range, I'm going to think about a number line that goes this way. It starts down here and then goes up, right? And both my arrows are pointing up. What is this very bottom number on my y's? -3. That's this guy right here. What's the biggest my y's are going to be? Infinity. Those arrows are pointing up. So to write it in our interval notation, we take our smallest and our biggest. -3 to infinity. We always put a parenthesis on infinities because we can never touch them. It can't equal infinity because infinity is an idea. Will it equal 3? Yeah, I can touch 3. Right there. Right there, I can touch it. Right there. Why? The first time I actually touched the screen on purpose, it doesn't get everybody of me. Love that. Go for it, my dear. Sorry, good question. So we're going to put a bracket on it. Exactly right. And what that means is my range, I can write this as an inequality. I can write it with a less than or greater than. My y's are going to be which way? Less than or greater than -3? Greater. They're getting bigger. The y's are bigger than -3. Can they be equal to? Yes. So our algebraic notation can be written as an inequality, or we can use the all real number stuff when that applies. And we will practice with this stuff bunches and bunches. All right, so then let's do our function test, which you did in Algebra 1, and our one-to-one function test, which you did not do in Algebra 1. And it's a super duper high-tech, ultra fancy, super scientific tool, also known as STEAK. Stick of power, stick of truth. Vertical line test means I'm going to hold my line vertically. And I'm going to make sure it never touches more than one place at the same time. So it can't cross twice in the same spot. That means my input, where my x is giving me more than one output. So if I take my vertical stick, or pen, or finger, to do this, and run it across my graph, is it ever touching that red line more than one time?
Yes.
Where?
Not at once. No, it's not.
Not at the same time. So it's never touching the line more than once. So that means it passes my test. So it is a function because it passes the vertical line test. It passes the vertical line test, which I will almost always write as VLT because I never get the right number of consonants in the word vertical. Notice how I never wrote the word vertical. All right, for our one-to-one function test, it is again my super duper high-tech, ultra fancy scientific tool, STEAK. But instead of doing a vertical line test, we're going to do a horizontal line test. Okay. So I'm going to hold my line sideways, and we're going to do the same thing. Does it ever cross my red line more than one time?
Yes.
Yeah.
Yeah. It's got 1, 2 places here. It's got 1, 2 places here. It's got 1, 2 places here. So it does cross more than one time, which means it fails. It does not pass my test. So it is not a one-to-one function. So no on the one-to-one. It fails the horizontal line test. Vertical line test tests if it's a function. It makes sure that each x goes to only one y. Each x goes to only one y. Each x goes to only one y. Our horizontal line test is seeing if each y comes from one x. So I've got 1, 2 x values that give me the same one. I've got 1, 2 x values that give me the same y answer. So that's what it's looking at here. All right, so clearly we're not going to get through all 3 graphs. We'll finish the other 2 up tomorrow because what we're talking about tomorrow we were going to use these for anyway. So we have just a couple minutes left, and I have a couple things I need to touch on. So the probability and statistics tests are in. If you look at grades on Canvas, like if you go into your grades on Canvas and you click this little button next to the probability and statistics test, you get this. We know what those are. It even gives you all kinds of data. It tells you the average. It shows you the median. What the values were at those quartiles. And if you pull up yours, the little blue box is where you are compared to everyone else that's taking the test. Okay? So the grades were like pretty, like, I'm not mad at that at all. Not mad at that at all. Okay, y'all? So that doesn't mean we get to, change the stuff. What are we doing? So I have homework 1. I know we only did 1 of these. We're going to practice with more of these tomorrow. We'll do the other 2, and we'll have 2 more new vocab words. This chapter covers a lot of things that don't necessarily feel connected, like it feels a little scattered. So we're going to do this as 2 quizzes. It's kind of a break point in the middle. So it's not going to be one massive test. Whoa. It's going to be 2 quizzes. So I have the dates of both quizzes up there, because those 2 quizzes will combine to make 1 test. What's up? Put it in your locker. I am not responsible for your book. Yeah, if you look in Skyward, you should be able to see your locker stuff in there.